Not everyone has finished yet. How can I move this figure? What could I do if I wanted to move that?
Like, what do you mean, like, move?
Mhm.
Like, no, like, really move or
Yeah, like actually move it.
tap it?
Oh, I'm sorry. Let me clarify. If I had a figure such as this, understanding how the smartboard works, how could I move it? Like, what ways could I move it? Pick it up. Well, it's not three-dimensional, so I can't pick that up.
You can move it.
What do you mean?
You can rotate it.
I could rotate it. Yeah, I could rotate. What else could I do? I could actually slide it, or I could move it side to side. What else could I do if I had like an image?
You can move it from slide to slide and copy it.
Okay. Yeah, but still here, I mean, you definitely have rotation. I could rotate it. Right, I could slide it. Right, up, down, side to side. Is there any way I could, any other way that I could move it?
You can shrink it.
I could shrink it. Yeah, I could actually make it bigger or smaller. Okay. Then another one that I could do, which I don't know if this is gonna, I could do that. I could flip it. That one's a little tougher to do on the smartboard. Okay, so what we're gonna focus on now, we're starting our next unit of geometry. Pythagorean theorem is geometry, but in the 8th grade we treat that as its own unit. So now we're gonna start our geometry unit. Okay, and we're going to start with figures. We're going to figure out all the ways that we can move them. So I want you to divide up your paper into 3 sections. Okay, you don't have to fold it. If you have a notebook, you can just separate it into 3 sections with a line. If you have a binder and you like to have it all folded and really visual, you could fold it. But you're going to break up your paper into 3 sections. We're going to go through 3 ways to move figures today.
I don't have to.
You need another one? You need another one? Try not to skip pages so it lasts the rest of the year. Just like every other lesson from our unit, all of them are recorded and posted if you need to refer back. Or I have a link on the Google Classroom to the page where all of the lessons are posted. Does anyone need more time to separate your paper? Are we all ready? Ready to go. Now, as the introductory day to our to this unit, you are going to be writing down some terms and definitions. These are terms that we want to constantly go back to. Okay, just like in the Pythagorean theorem unit, when we always talked about the legs, the hypotenuse, the square root, we tried to use those terms instead of just saying like, oh yeah, that side, or that, you know, that operation. Right, so we want to use specific terminology. So there are 3 ways that we can move a figure from one place to another. We call these transformations. So at the top of your paper, I just want you to write the word transformations because this is what we're going to do today. Transformations. What do you think of when you think of the word transformation? What comes to mind?
Transformer.
Transformers. Yeah, what do transformers do? Yeah, they change. Right now, the idea of a transformer is a little bit different than figures when we transform them. So we're going to go through all different ways. So the 3 things that we're going to go over today, we can slide a figure, we can reflect a figure, or we can rotate it. Okay, so we're going to describe these movements and come up with ways to do that. So the first thing we can do is called a translation.
I put that on the first.
Translation is the first way we can move a figure. And translating a figure is sliding it. So you're going to write down what's underlined. Moves every point of a figure the same distance and in the same direction. So there are some examples here. Write this down. Everything in red you're going to write. This is your first box. Your first movement, translation. So these three examples of translations here on the right, you don't have to draw them, but it is good to know how the figures are moving. It's really just like we did on the previous slide with the star, just sliding it. I can slide this original green triangle, I can slide it to the right. And if you wanted to be really specific about how much I slid, I actually moved it 1, 2, 3, 4, 5, 6 units to the right. I actually moved it on the graph 6 spaces or units to the right. You could also translate a figure up. If I take a look at these figures, and really we use the coordinates. So if I went from these 3 points to these 3, I actually translated that whole figure up 4 units. Another option, even though this is diagonal, you're actually moving up and over. So we can do that diagonal translation as well. So that is the first way that we can move a figure. Is anyone still ready? We're going to skip that. The second way that we can move a figure is called a reflection. And this is actually flipping a figure. So you're going to write this down. Reflection. And a reflection flips a figure over an imaginary line. That can be horizontal, vertical, or slanted. That line is really important. We call that line the line of reflection. The line of reflection. So make sure you have that written as well. Now this is a really great term to draw an example for. Things to notice in the image. The original figure and its new image after we transform it, they are the same shape and the same size. We have not yet changed the size of the figure. And they're also the exact same distance from the line of reflection. What that means here for this vertical reflection. If this is the line of reflection, these two little points of the triangle are both 1 unit away. Right? Where the right angle of that triangle lies for both figures, it's 5 units away. And then the top part of the triangle for both sides, again, the same distance, 5 units away. You can see that in all 3 examples here. The corresponding points on the original figure and its new image are the same distance. Right? So whichever example of this you would like to draw, make sure you have one of them. If you're a fast drawer, you can draw multiple. And it is possible to have a line of reflection be diagonal, like this example here. And again, with our translation, our sliding, and our reflection, our flipping, we have not changed the size. The size of our shape hasn't changed yet. Still writing?
Okay.
Yeah, this one's a little longer. The last way that we can turn a figure is a rotation. So a rotation, which is turning a figure, moves the figure around a fixed point. So the fixed point has a name. And like the point that we rotate the image around is called the center of rotation. There's two ways that our figures can move. They can move clockwise or counterclockwise. And both examples are represented here. The green figure is the original. And so here, this triangle, I take it and I rotate it. Now the problem with the rotation on the smartboard is that the rotation on the smartboard just rotates it around this like middle imaginary point. The center of rotation is an actual point. If this is the center of rotation, I'm taking my image and I'm rotating it up. If this is my center of rotation, I'm taking my image and I'm rotating it down. So on a clock, that center of rotation is actually like the center of the clock. It's what everything spins around. This is the transformation that I struggle with the most. I would draw one of them just so you can see that center of rotation and how the image would move. Something else to notice, again, very repetitive at this point, all three transformations that we're learning today, the shape of the figure is not changing. We will get to the shape of the figure changing. Like you had mentioned before, that star could have gotten super small or super big. We will get to those, but we're not there just yet. For here, these shapes don't change their size, they're just changing their location. Whether we're sliding it by translating, flipping it by reflecting, or rotating it and like turning it. The shape's size doesn't change. Now, as we continue on this week, you're going to identify, you're going to look at a figure and see how it has transformed. And it could be a combination of things. Maybe we translated it and then reflected it. Maybe we rotated it and then reflected it. The goal here is that you not only know the ways that a figure can move and change, but also how to identify what happens to get the figure to move or change. How could you describe translations, reflections, and rotations to a sibling or someone who missed class? Right? Because the easiest way to remember these three things, translation, reflection, and rotation, is to be able to put it into your own words. How would you explain any of them, any one of them? Michael, give me one.
Rotation.
Rotation. Okay, so explain a rotation.
When you rotate it, then it's rotating around this one fixed point.
Okay, does the fixed point, that center of rotation that we call that, it's really what we're turning the object around. Does it have to be a point on the object? It doesn't have to be, and that's actually for me, like I struggle a little bit with rotation because if I had a shape like this and this was my point of rotation, I could spin it around. What I struggle with is if I have a shape like this and the point of rotation is up there. So imagine taking this whole thing and like rotating it up. That's what I struggle a little bit with. Okay. How about reflection or translation? How can we explain it? That's a very visual. The rotation's very visual. For those of you who are visual, you're gonna have a lot of fun in this unit. How about reflections or translations? What do you think? What words come to mind that you could use to describe a reflection? Or what does that word mean to you? Like look at, yeah, and what happens when you get your heads off the desk and sit up? Are you kidding? What happens when you look in a mirror? What do you know about the object that you're looking at and the object that you have? Everything's flipped in reverse. If you ever, and you know when you see this a lot is like if you take a selfie, right? Where like if you're holding something in your left hand, it actually in reflection looks like it's your right hand, right? Because it is an actual reflection. Everything's the same size. It just changes its location. How about a translation? This word doesn't really associate as much with the word, with its definition, right? Reflection and rotation, you could pretty much figure out what you're doing to the figure. What about translation? Is there something that we could use to remember the word translation has to do with sliding a figure? Is there a way we could use that word translate? You may have to come up with your own way of remembering the word translate. That one doesn't directly relate. Unless you can come up with something. And anyone wants to share? When I think of translate, I think of language, but I don't know how I can, like, in my mind, make that attached to sliding a figure. So that's the extra we have. Okay. So you're going to do two things. First, you're going to describe, you're going to answer this DOL. When a figure is translated, reflected, or rotated, what is the same about the figure and its image, and what is different? Now, you can use the examples that you have written down of a translation, a reflection, and a rotation. Okay, before you start your DOL, though, let me just show you what you're going to do after. I have to pause this.